Hi everyone, welcome back. So this topic that we're working on today is group data. So what we've been working before is individual data or data set out as in a frequency table, but it's still individual data, whereas now we're going to work with group data. So things are a little bit different. So this time it's important to note that when calculating the mean and standard deviation of group data, you need to use midpoints of the class or the range or the section, the group that the data is separated into. And to do this, we use the following formula. So the class midpoint equals the upper class limit plus the lower class limit divided by 2. So you can see that the class midpoint is just the average of the class. And I'll show you an example of that shortly. When we're calculating the median and the quartiles here, we use true class limits other than stated class limits. And again, I'll show you what that means to create a cumulative frequency polygon, which we did back last term. So you should remember what that is. If not, look back on your notes. The first quartile is found at 25% of the total frequency, median at 50%, third quartile at 75%, just as it was before. Okay, so first quarter, second quarter, third quarter, everything's exactly the same. However, the formula we're going to use is a little bit different. So here it is. So the formula for the median when we're working with group data. So in grouped data. So it's only different when we're working with group data. And it's L plus M over F times W. And what those letters mean, L equals the lower class limit, W equals the width of the class, F equals the frequency of the class, and M equals the median term in the class. And we're going to go through an example so you can see where those come from and what that actually means. So what we're given usually is something called stated class limits. And stated class limits aren't really the true or real class limits, particularly when we're talking about continuous variables. Remember, continuous variables can take any values within a particular range. So decimals frequently appear when we're talking about continuous. So for continuous variables, the true class limits generally include the lower limit and exclude the upper limit, and usually at half values, because really it's half of the value below that as well. For discrete variables, the class limits are generally inclusive, and the true class limits are considered to be at half values for consistency. Now, may be very difficult, so we'll look at an example to see. Please note also that we cannot find a mode when we're working with group data, only a modal class. So that should be okay. All right, so let's have a look at this problem. So the values of orders for a party plan sales campaign are tabulated or calculated. That just means below. Find the mean, median, modal class, range, and interquartile range from the table. So you've got all of these ranges, and each one of those are called the stated class limits. That's what it says it actually covers, stated class limits. And you've got the number of orders in each of those classes between them. Below them, which is just set out in a frequency table. But we don't need to use those stated class limits. We actually need to use the true class limits. And if you have a look down here on the table, I've already set up what would be considered the true class limits for you. So $50 to $59 would really include any order that was valued from $49.50 up to $59.50. And if we think about that, if an order costs more than $49.50 and we're rounding to whole dollars, which is really what it's talking about here, we would round that up to $50. Just similarly, if anything was, if an order was valued up to $59.50, the rules of rounding say if it's up to 50, we would actually round down. So really, it's would be 49.59 and 59.49 here, because you can see that if it was actually 50 cents, it would go up into the next one. So hopefully that is clear here. But we don't have up to 49 here, 49 cents anymore. We only have up to 45. Okay, I hope that makes sense. Now, to work out the class midpoint, we need to find the average of the true class limits. So equals average of the true class limits. So that's what the midpoint is. So to do that, that would be 49.5 plus 59.5 divided by 2. And that value would be 54.5. So it's just a matter of finding the middle of the class. And you can see each one of these classes actually go up in the same amounts. So each one of these class midpoints is just going to be 10 more than the previous one, because each of our ranges in this case is 10 more than the previous one. So I'm going to fill in all of those. Okay, now the F values frequency comes straight from this table here, and it's just transcribed down into our vertical layout. CF, cumulative frequency. So just like we worked this out before, the first frequency and cumulative frequency is the same. The second one is going to be our total cumulative frequency plus the next total, 8 plus 19, which is of course 27. The next one is going to be 27 plus the next one, and so on. So you don't need to show all of that working. I've just done some of them for you so you know where the values come from. So I'm going to fill in all of these. Now, remember I said your total of your cumulative frequency column, or your last value, should equal the total of your frequency, sum of F, 417. They should be the same. So if they're not the same, you need to stop and go back from here. Now, Fx is literally just frequency times class midpoint. So the first one would be 8 times 54.5 equals 436, and you would keep going like that. They're not always going to go up in the same order. Some are going to be higher, some are going to be lower. Depends on what you are multiplying by. And you'll see why I'm bothering with this shortly. So you can see what we're doing here with the table is really no different with what we did with our individual or frequency table data. You're just working with different, slightly different values. Sum of Fx, we need the total, 76.5. Okay, so we've got that total. Now we actually need to find the values. So mean, median, modal class, range, interquartile range. I'm going to start with the mean. So the mean in this case is the same as our frequency table data. Sum of Fx over sum of F. So because we've already done this in our tables, we can substitute straight in. So 104.26 is our mean, our median. Now, formula is still exactly the same as it was, nothing's changed there. So it's an n plus 1 over 2 score. We've got 417 scores that we've had so far. So that means it's going to be the 209th score. Now, we need to go up and look at our cumulative frequency column and see where 209 falls. So, in this one, up to here, is 173. So this one in here is going to be the 174th to the 258th score are going to fall in that row. So that is the one we are interested in here. That is going to be our median. So you can see it's exactly the same as what we did with frequency table data. It's no different whatsoever. So it falls in the 99.5 to the 109.5 range. Now, this is where we use that formula I gave you a bit above. So, which term in the class? You're going to use that formula, which was up here. What is it? M equals median equals L plus M over F times W. M equals L, what was it? Oh, better look back. M equals L plus M over F. Let's make that a little bit smaller. M over F times W. Okay, so where do those values come from? So L equals the lowest value in the class. Lowest value in the range that we want. So our L equals 99.5 because that's the lowest value in the range that we're after. Our W equals, it's the width of our class. So how far is it between 109.5 and 99.5? So in this case, that's going to be equal to 10. Our F value is the frequency of our class. So how many appear in the class that we're interested in? And that will be, oops, this value here. There's 85 in the class that we want. And the M value is which term in the class are we interested in? How many values appear in the class that we want? So let's have a look up here for a second. Now, we want the 209th score, but we need to know where that falls in our range. 209th score, up to the previous one before that, there's 173 scores. So we need to figure out how far in the class that we want is the score that we're interested in pairing. And it's 36 places into the range that we're after. So that's what our M is in this case. So let's find that here. Any questions? It's probably best that you ask me in class. So 99.5, substitute these values that we've got in, is going to give us an answer. And at 103.74 is our median value here. Now, our modal class, we just, again, look for the most frequent one, and the one with the biggest frequency here is the one with 85 in it, and it's in the 99.5 to 109.5 range. So that means our modal class is going to be in the $100 to the $109 range. And notice these are stated as this is the stated class limits, not the true class limits. You don't use the true class limits to state answers, you use the stated class limits. All right, I'm going to do one more here, and then I'm going to stop it and do a second recording to work out the interquartile range. So the range here is found by taking the true upper limit of the last class and subtracting from this the true lower limit of the first class. Okay, so 159.5 is our true upper limit of our last class, so that's that value there, and the true lower limit of our first class is the 49.5. So you literally just use what you already worked out to state those values. So that's going to be 110. Now I'm going to finish that up there, and then I'm going to do the interquartile range. So I'll see you shortly.